Okay, on this video we're going to take a look at solving inequalities using the multiplicative property. So remember, inequalities are solved the exact same way as equations, with one exception. When we start using multiplication or division, we do have to take into one special little step. So one thing that we can think of when we're multiplying, or dividing by a negative number, it means the opposite of. And I know I brought this up in other videos, because if I say 2 times negative 1, well, I actually should say negative 2 times 1, I'm asking, what is the opposite of 2 times 1? Well, the opposite of 2 times 1 would be negative 2, because 2 times 1 is 2. The opposite of that is negative 2. So it's just one of those things that when we think of multiplying or divided by a negative number, we're kind of thinking of what is the opposite of. And that's going to apply to the inequality sign as well. In other words, when we multiply or divide by a negative number, we will flip the sign of that number and flip the inequality sign. So both of them flip, okay? So if we had x is greater than 2 and we multiplied by a negative number, we would have x is greater or less than whatever we multiplied by. Say we were multiplying by negative 3, then we'd have negative 6, okay? We have to multiply both sides. That's not the greatest example, actually. So we will see one in just a moment because we're going to flip the sign on the second one. So we're going to solve for the variable. These are kind of the steps. Did we multiply or divide by a negative number? If yes, flip that inequality sign. If no, then just go to step number 2 and make sure it's in the right order. All right, so for this one, we have 8u is greater than 72. So to get u by itself, I'm just going to divide both sides by 8. So 8 divided by 8 cancels. U is greater than 72 divided by 8, which is 9. All right, that one is all done. Next one, I want to get u by itself, so I'm going to divide by negative 5. So I have 15 divided by negative 5 is negative 3. Negative 5 divided by negative 5 is 1, so I have u. I divided by a negative number, so instead of less than, it's going to be greater than, like that. And then I also want to switch the order here, so I want to flip these around so that it's u and then negative 3. And remember, this is kind of open to the 3 here. It's my kind of evil little Pac-Man guy there. So I still want it to be open to the 3 here when I rewrite it. Okay, because he's still hungry. He still wants the negative 3, which is bigger than u. That's what this is saying. Okay, so I'll take the little Pac-Man guy away so you can see it's u is less than negative 3 because we flipped it back around. So I know we flipped it from less than to greater than for this one, but the reason it went back was because we literally flip-flopped the entire equation, so that we had variable inequality sign number. I'm very picky about that order because it makes it much easier to graph if you have it in the correct order. All right, so let's do this very last one. So we have negative 12/7 being multiplied by w. Anytime I'm multiplying by a fraction, I'm actually going to multiply by its reciprocal to clear the fraction from that side. So I'm going to multiply by negative 7 over 12 on both sides. 7 divided by 7 cancels, 12 divided by 12 cancels, and I'm left with just w. I'm multiplying by a negative fraction, so I do need to flip this around. It's not going to be less than or equal to, it's going to be greater than or equal to. And then I'm going to have negative 8 times negative 7, that's positive 56 over 12. Let's see, so that does actually cancel down a little bit. I think they both divide by 4. So let's try that. They both divide by 4. So 56 divided by 4 is 14, and 12 divided by 4 is 3. Okay, so I reduced this, so let me rewrite it so you can kind of see it without the equal sign there, because we're not going to write equals, we're going to write greater than. So w is greater than or equal to 14/3, which you could turn into a decimal. The only problem is they haven't given me any instructions on rounding, so I would leave it a fraction, just to make sure that I don't get marked off for rounding when I wasn't supposed to be rounding. Okay, so we're going to try one more here. We're going to look at a word problem, which just applies what we're learning to more of a real world situation, gives us kind of a scenario. So Raphael will spend at most $21 on gifts. So this is a limit, at most $21. He can't spend more than the 21. That's the most he will spend. So far, he has spent $13. So he's already taken 13 away from the 21 that he had. What are the possible additional amounts he will spend? So we're going to do C. Write your answer as an inequality solved for C. So C is the additional amount in dollars Raphael will spend. So C has to be less than or equal to the 21 that he had minus the 13 that he spent. So we just need to combine these. So C has to be less than or equal to $8. That's all he has left to spend on his gifts. So that was just translating that kind of simple word problem into a one-step equation there. Or one-step inequality. I said equation. We're in inequalities now. So go ahead and give this a try on Alex. See if you can solve inequalities using the multiplicative property.